For our physics project, we went on the pirate ship. One of the laws of physics that applies to the pirate ship is the conservation of mechanical energy. At the top of its swing, the pirate ship has potential energy, and potential energy equals mass times acceleration times the height. The mass is the mass of the ship plus the riders. The acceleration is the acceleration due to gravity, and the height is the height or magnitude of the swing. Also, at the bottom of its swing, the pirate ship has kinetic energy. Kinetic energy equals 1/2 mass times velocity squared. The mass of the ship is the same, and the velocity is the speed at which the ship is traveling at.
Also on the pirate ship, Newton's first law of motion applies. Newton's first law of motion is the law of inertia. That's when an object's in motion, it stays in motion, unless acted upon by an outside force. This applies to the pirate ship because the pirate ship, if there wasn't an outside force acting on the pirate ship, Newton's first law of motion would prove that it would continue to swing all the way around. But since there's an outside force, it stops on one side and swings back the other way.
While riding the pirate ship, I noticed some changes while I was riding it. First, the ship, it lost height when it swung from the top of its path to the bottom of its path. And while it lost this height, it also lost potential energy. But this potential energy didn't just disappear, it was converted to kinetic energy. When the kinetic energy increases, so does the velocity. I found this true at the bottom of the ship. It was moving faster than at the top of the ship.
As the ride happened, you could also see that there was a change in the variables with Newton's law of inertia. As the ride was happening, when the ship got to one of its highest points in its swing, instead of continuing to move around all the way around in a circle, there was a different force, an outside force applied to the ship, which made it stop for a second and then change direction in the other way. This is true because when we were on the ride, I could feel that it slowed down towards the top as there was an opposite force being applied to the ship, and then we started going in the opposite direction.